Hi, Mayank. Hello, Kavita. Hello, everyone. I hope all of you are doing good. On behalf of Meritnation, I welcome you all to NEET Bytes session today. In the previous session, we have already started with atomic structure, right? Hello, movie maker. Hello, Yash. Hi, Saurabh. Hello, Moin. How are you? I hope all of you are doing good. So, I'm Vishali, and today I'll be taking your session on electronic configuration. All right, so let's begin with the session, right? So the session basically is on electronic configuration. We'll also be discussing about the quantum number. This quantum number topic is very, very vital for NEET exam because many questions are asked in every year on this particular topic itself. So let's begin with the topic. Starting with the quantum number. Yes, all of your doubts will be taken, don't worry. So starting with the quantum number, what do you mean by quantum number and what is its use? First of all, we'll be studying this topic in brief, and then we'll be doing the questions based on this. So there are total 4 quantum numbers that we'll be dealing with. What is the use of quantum number? Quantum number basically tells us the address of any electron. Okay, so the 4 quantum numbers that tells us how to locate the electron are: number 1, principal quantum number; principal quantum number is basically denoted by the letter N. And what does it tells us about? It tells us about the shell in which the electron is present in. Then it tells us about the size of the shell or the size of the entire atom. If the N increases, if the number of shell increases, then the size also increases. Because if the number of shells increases, like if the nucleus is present in between and the number of shells are increasing, so it will be more farther away from the nucleus. And if it is farther away from the nucleus, obviously the size will also increase, right? Savan, as you're asking me why we need quantum numbers, we need quantum numbers to locate the electron, to tell where the electron is present, its address in the entire atom. All right. Then the third thing that it tells us about is energy. If the N increases, the principal quantum number increases, then the energy also increases. Energy of the electron also increases. Okay. Then the fourth point is that the principal quantum numbers also tells us that how many electrons can be accommodated in a particular shell. The total number of electrons that can be accommodated in a shell is equal to 2n square, where n stands for the principal quantum number. Okay? So the total number of electrons in a shell is equal to 2n square. For example, if n is 1, then the total number of electrons will be 2. If n is equal to 2, the total number of electrons will be 8. Right? So this is all about the principal quantum number that we need in solving the questions. Then let's move on to the second one. The second quantum number is again very vital one, that is azimuthal quantum number. Azimuthal quantum number is also known as subsidiary quantum number. And it is denoted by the letter small l. Okay, now when it is denoted by the letter small l, what does this L tells us about? This tells us about which subshell a particular electron is present in. Okay, the subshell the electron is present in. What is the value of L now? That is this topic, like what is the value of L is asked in many questions. The L value can lie from 0 to n minus 1. For example, if the value of n is 2, then the value of L can be 0 to 2. That means it can be 0, it can be 1, and it can be 2. Okay, now as I told you, the value of L tells us about the subshell. So if L value is 0, which subshell will it be present in? It will be present in S subshell. The subshell name will be S. If L is equal to 1, yeah, obviously, it won't be, it will be 0 and 1 because it's 0 to n minus 1, right? So, yeah, its value will be 0 and 1. If the value of L is 1, then the subshell will be P. Yeah, exactly. If the value of L is 2, then the subshell will be D. And if the value of L is 3, then the subshell will be F, right? So we have 4 subshells basically, S, D, S, P, D, and F, right? All right, great. So I hope all of you have understood this much. Then let's move on to the next quantum number. The next quantum number is a magnetic quantum number. So I hope all of you know what is magnetic quantum number. Magnetic quantum number is basically denoted by the letter M with a subscript L. Okay, so what happens is when the electron is revolving around the nucleus, it also generates magnetic field. Okay, now this magnetic field changes the orientation of the orbital. Okay, so based on the orientation of the orbital, we have different values of the magnetic quantum number. The value of magnetic quantum number, that is M, lies between minus L to plus L. All right. For example, if we have a subshell, that is D subshell. So the value of L will be what? The value of L will be 2, right? So the value of M can be what? M can lie between minus 2 to plus 2. That means it can be minus 2, it can be minus 1, 0, plus 1, and plus 2. Right? All these value can be there. All right. So this is all about magnetic quantum number. And one more thing, that how many values of the magnetic quantum number can be there? How many? Can anyone tell me how many values of magnetic quantum number can be there? The total number of values can be 2L plus 1. So you can see over here, like L is equal to 2. So 2L plus 1 will be 5. So we have 5 values of M over here. Right? So this is all about magnetic quantum number. Now let's move on to the last quantum number here. That is spin quantum number. Spin quantum number is denoted by the letter M with a subscript S. Okay, now what does spin quantum number tells us about? It tells us about the direction of spin of the electron. Okay, electron about its own axis. So the value of spin can be plus 1 by 2 and minus 1 by 2. What does this plus 1 by 2 and minus 1 by 2 tells us? That whether the direction of spin is clockwise or whether it is anti-clockwise. This is anti-clockwise. So this is spin quantum number, magnetic quantum number, principal quantum number, and azimuthal. I hope it's clear to all of you, the brief about this quantum number topic. Right, now let's move on to the questions, how the questions are asked on this topic. So we can see over here, this question was asked in NEET 2018. Which one is a wrong statement? The first statement here is the electronic configuration of nitrogen atom is 1s2, 2s2, 2px1, 2py1, 2pz1. Okay, the second statement is the value of m for dz square is 0. An orbital is designated by 3 quantum numbers, while an electron in an atom is designated by 4 quantum numbers. The total orbital angular momentum of electron is s orbital, in s orbital is equal to 0. Why is it A? Can anyone tell me? As all of you are answering me A, we can clearly see that in the last 2p orbital, the electron here has an opposite spin. So we all know that according to the Hund's multiplicity rule, before the pairing starts, the electron should be present singly in the degenerate orbitals and with a parallel spin. But here we can see that they're not present with a parallel spin. The spin of the last electron is opposite. So that means this first statement is itself wrong. Then next, all the statements are absolutely right. The value of m for dz square is 0. The orbital is designated by 3 quantum numbers. We don't need to tell the spin quantum number for designating the orbital. And for electron, we need all the 4. Then the D1 statement is also exactly right, that the orbital angular momentum is 0 for s orbital. Right, let's move on to the next question now. The next question is, how many electrons can fit in the orbital for which n is equal to 3 and L is equal to 1? So you can see that n is equal to 3 and L is equal to 1. This clearly tells us that which orbital is it? It is 3p orbital. Right? 3 is the principal quantum number and L is the azimuthal quantum number. Okay, so the number of electrons that can be present in the 3p subshell. If we are talking about the subshell, then the total number of electrons that could be present in 3p subshell are how many? 6, right? Because in the 3p subshell, we have 3 orbitals, and in each orbital, we can have 2 electrons. So total electrons can be filled is 6. So this question was asked in 2016 NEET, and according to the answer key, the answer was 6. But one more thing you have to keep in mind, that it's written orbital here. Now, when there is a difference between subshell and orbital. Subshell, we are considering all the 3 orbitals, and in the orbital, there can be only 2 electrons. In the orbital, in one orbital, there can only be 2 electrons. So the answer should be 2. Because in one 3p orbital, there are 2 electrons. And in the entire 3p orbitals, Govind Sharma, in the entire 3p orbital, हमारे पास, in the subshell of 3p, we have 3 total orbitals. हमारे पास 3 sub-orbitals हैं. In each orbital, हर एक orbital में 2 electrons आ सकते हैं. तो 3 orbital में 6 electron आएंगे, right? So the answer here is 6 if the subshell is given. If orbital is given, it should be 2. Okay? Then the next question here is, what is the maximum number of orbitals that can be identified with the following quantum number? Now the 3 quantum numbers are mentioned over here. And this question was asked in 2014. N is equal to 3, that is the principal quantum number. L is equal to 1, that means it's P, right? And the magnetic quantum number is also given. So that means the orbital is also mentioned, right? According to the 2 quantum numbers, we can get the subshell. We can get the subshell in which it is present, but the last quantum number, magnetic quantum numbers, also tells us about the orbital it is present in, right? So the 3 quantum numbers tells us about a particular orbital. It tells us about a particular orbital. The answer is 1. only one subshell one orbital will have all these three quantum numbers. The third quantum number will be different for different orbital. Okay, so this is our question number, this question, and I hope it's clear to all. Any doubt you can ask. The last question is that which is the correct order of increasing energy of the listed orbitals in the atom of titanium? Spin tells us that in which direction the electron is moving around in its own axis. Okay? Then titanium. The atomic number of titanium is 22. Now, in order to arrange them in increasing order, there is a rule that is followed. The rule that is followed is which rule? It's N plus L rule. The sum of N and L quantum number tells us that which orbital will have higher energy, which subshell will have higher energy, right? So you can clearly see over here. Yeah, the answer is C, as all of you have exactly mentioned here. Why? Let's see that. 3s. What is the value of N plus L? 3. For 3p, the value of N plus L will be 3 plus 1, that is 4. For 4s, the value for N plus L will be 4 plus 0, that is 4 itself. And for 3d, the value will be 4 plus 2, that is 5. Okay, now more is the value of N plus L, higher is the energy, right? So you can clearly see the value of 3s is least, then we have 3p and 4s, and then we have 3d. Now, if you can see over here, which have the same value of N plus L, how to differentiate in that case? In that case, you have to see the value of N. Higher is the value of N in this case. As N increases, the energy also increases. All right. So in this case, 4s will have a higher energy in comparison to 3p. So 3s will have least. Yeah, 6 it is. 3s is least, then 3p, then 4s, and then 3d. So this is the order for increasing energy in the case of titanium. Okay. And if suppose instead of titanium, you're given hydrogen, in that case, you don't have to see the value of N plus L. In case of hydrogen, you just have to see the value of what? Only the value of N. So in that case, if you're having 1s, that will have the least. After that, we have 2s, and 2s and 2p, although there is difference in the value of N plus L, but we'll only see the value of N in order to compare the energy. Okay, so here it will be like this: 3s, 3p, and 3d. This is the case in case of only hydrogen. Except hydrogen, we'll only use N plus L rule for rest all of the elements present in the periodic table. I hope it's clear to all. These were all the questions that were asked on the quantum number in previous year. I hope the entire session is clear to everyone, right? So if you have any doubt or query, you can obviously ask me, and I'll see you in the next session then. You can have the URL for the premium courses and join it. Thank you so much. It was great taking this session. Bye-bye, everyone.